Okay, and number 6 of worksheet 2 says we have this automobile, it's 8,000 newtons, installed 1/4 of the way across the bridge, and we're supposed to compute the additional reaction forces at supports A and B due to the presence of the car. Okay, so let me redraw this extended free body here. So here's the bridge, and there is a downward force on the bridge from the car, and there's going to be some reactionary forces at A and at B. So I'm going to call this force B and this force A, and this I'm going to call weight of the car. And I could write an equation like FA plus FB equals the weight of the car, which is 8,000 newtons. The problem is there's two unknowns, FA and FB. So I need to do a torque equation. And I could pick any point I want to be the pivot point, but the smarter places would be at the ends, because then those forces don't create a torque and they're unknown to me, so it gets rid of one of the unknowns. So I'm going to pick this end down here to be the pivot point. Okay, so in that case then I've got the torque from B has to be equal to the torque from the car. The torque from B would be the force of B times the distance away. I don't know the distance, so I'm going to say it's equal to 4x. And then for the weight of the car, it's going to be 8,000 newtons times the distance away, which would be 3x. So I can solve for the force of B. Force of B is going to be equal to 8,000 times 3 divided by 4, that's 6,000. 6,000 newtons. Since I've already written this equation up here, FA plus FB equals 8,000 newtons, I should be able to easily figure out what the force of A is. Force of A is going to be equal to 8,000 newtons minus the force of B, which I just found was 6,000 newtons. So that means F of A is equal to 2,000 newtons.